This is Todd Frazee, and this is the tutorial for the S60-144 CAM for the base plate. This is a steel part made out of mild steel, so it's a steel that's fairly easy to machine. Okay, we're going to go over and make sure you have your model running, and we're going to machine the side that has the countersinks on the face first, which might be the backside of the model, the way you modeled it. Okay, so you got to make sure you've loaded your mill library for your tools in HSM, and we're going to start off. Now let's talk about approach on this. So we need to machine it from this side, and to be thorough and precise, we're going to run around the outside with an end mill to make the plate the correct size. But if we were to look at the opposite side, most of the holes are through, but we have a bunch of edge breaks that would be nice to put in, so it's nice and clean off the machine. So you could approach this as a single-sided part. There's some clamping issues with having to go around the outside, or and then you could do those chamfers by hand. But this is a CAM class, so we're gonna do it all through machining, and we're gonna think a little bit about our fixture holding on this one. So we're actually going to do more than one program. So if we have a plate like this and we hold it in a vise, we're not going to be able to machine the side faces. So what we're going to do is we're going to approach this as if it's sitting on top of a fixture block of aluminum or something. It could be held in a vise, it could be on the table. And we're going to do staged programs. So we're going to do a program assuming we have clamps clamping around the outside edge of this to hold the part down. And then once holes are drilled through for these 4 holes, we'll have a program that'll run that would have been run before the part is put on the table, that's going to tap and drill holes that line up with at least 2 of these holes here. And then we can screw screws into those holes and remove the clamps and run a program that goes around the outside. We can then flip the part, put it in a traditional vise, or you could have it aligned to some of these higher precision pins and clamp it again. And you flip it, and then that'll allow you to do the countersinks on the opposite side. Alright, so here we go. So let's go ahead and set up our jobs, assuming that. So I'm going to set up a job. It's going to be milling. The comment is going to be S60-141 op 1. Okay, and our relative size box. Okay, so our component was close to a bar size, but when I went to go purchase it, it wasn't available in 3.5. It was available in 4-inch. So we're going to use relative size box. We're going to add stock to all sides. So in our x-axis, let's add on 0.03, and then in our negative offset, we're going to put in the same amount, 0.03. So our instructions for the saw is going to be to cut this blank 1/32 longer than it is. In our y-offset, we were only able to get material that was 4 inches, so we got a 1/2 inch of material to account for. So we're going to go 0.25 on the y plus and same on the x. Okay, so that material needs to be removed. Okay, in our z-offsets, we're going to leave it at stock thickness because our drawing allows us to do that. And we're going to select our origin. Now it could be somewhat academic if first operation, as long as it's something that you can pick up on. I'm going to assume that we're going to pick up on a corner, and we're going to use the stock for the first operation because that's what we're referencing, because we haven't machined any and qualified any edges. Before we go to that, we're going to change our orientation. So right now Z is facing down as if we're machining the opposite side of the part. What we need to do is set our orientation, and instead of being stock orientation, we're going to go Z-axis and X-axis. So I'm going to select the top face of the part, and the X-axis is already set. So And we could select the x-axis, but it's already set. We want it pointing to the right. Okay, so now we can set our orientation of our origin. And we're going to use a stock box point, and we're going to use the bottom corner 3. The reason I'm selecting the bottom is I'm going to be using a fixture to hold this. And so when I indicate the machine end, I'm going to find that corner on the fixture, and however our part registers on it, the fixture will be the top plane of the fixture, which is actually the part rests on, which would be the bottom of the actual part we're machining. It's a little bit academic. It's just what's important is that the instructions show the operator how to set up the material in that particular fixture. Okay, so program name 141.1, and our program comment is going to be S60-1. I'm going to add to this comment, I'm going to say clamps side 1 clamps. And that's going to denote that clamps need to be in place for this program. Okay, we're going to accept that. And we're going to alter the name of the job to be S60 op 1. Clamped. Actually, we're going to say side 1 clamp. Okay. And then we're going to have an operation where they take the clamps off, they'll hold around the outside so that we've drilled through these holes, and then we're going to put screws in. So let's do this. We're going to duplicate the job. And we're going to edit the name. Okay, it's going to be op 2. We're going to leave all the other settings the same. It's going to have a 2 on the end of the program name. And it's going to be op 2 side 1 screws, or screwed, either way. Okay, so we can take this description and modify it as well. So this is op 2 side 1 screwed. So it's going to be screwed in place for that operation. So the clamps will have to be removed, and then we screw it in. And really all that operation is going to do is chase the outside of the part and remove the stock on the outside. Okay, now we're going to take this this one that we just created, this job we created, and we're going to duplicate it again. So we're going to call this S60-141 Fixture. Now there's a couple ways you could approach this. This is a pretty simple part. I'm calling the fixture the same place as the corner on the stock. That could be debatable. If you were actually going to design a fixture, you would put it on a reference on that fixture itself. My philosophy on this is we would set our origin where we anticipate the corner of the stock being, and then after the first time we run the part, you're going to have a witness line around the outside of the part, perimeter of the part from it cutting it, and that'll be in your fixture, so you'll be able to visibly place your stock, or physically have an edge to bump up against, that you'll be sure to have your stock material within your origin. So As long as we're using that same corner, we should be good. Alright, so this again is a program you'd only run once. It's going to drill some holes in a plate that are threaded for screws to go into. Okay, so we're going to call this just S60-141 Fixture 1. Okay, in case we have more than one fixture. And I'm going to call this 0. Okay, for fixture, because it's not op 1, it's not 2, it's a 0. You might have to have a different numbering scheme for that, but that's what we'll use for this. And we're just going to call this S60-141 fixture. Screw fixture. And let's change the description here. And I just realized I didn't put the correct part number on all of this. 141. So I'm going to make sure you do that. Okay, so we're going to have one more operation. That's going to be side 2. And we're going to be looking at the part with it flipped 180. Okay, I tend to flip around about the y-axis because if you are holding it in the vise, it keeps your datum against the fixed jaw of the vise, which is more stable. So we're going to create a new job, and it no longer has material around it. So it's going to be the S60-141 op 3. And because we said side 1 on the other one, we're going to call side 2 in our comment here. Okay, we're going to do relative size box, no additional stock. We're continuing from the previous job. Our orientation is fine for our origin, except we want to keep it on the bottom of the part. So we're going to move corner 3. Okay, and that places it still with our datum on the top of our fixture, not the part itself. So if it varies in thickness, our fixture origin is still the base of the part. Okay, and we got our S60-141 op 3. We're going to call it side 2. And you have different options of how you want to handle this. You could screw this down, you could clamp it down, it doesn't really matter, or you could put it in a vise. So that back left corner of the machine part that's qualified will give us our accuracy for the placement of the work we're doing on this side. And really all we're doing is coming around with a spot drill. And the holes are already drilled through, and we're spot drilling every location so that we have an edge break on each of the holes. And I again put the program comments where the program name should have been. So this is going to be the 141, and it's the third program. Let's accept that. Let's give it a name. S60-141 op 3 side 2. Okay, so we've got all of our operations in play here. Okay, all right, so let's go to operation 1, and we're looking at it as we would in the machine. Okay, so we have a bunch of holes that all need to be piloted, and then we have threaded holes on the outside. We have close tolerance reamed holes. We have a loose tolerance hole here, which according to our drawing is an 1/8 inch plus or minus 5. And then we have our bolt clearance holes. Now our countersinks are 82 degrees, so we can't use the spot drill to make those cones. But we can come with the spot drill and just spot where the through drill is going to go first. Okay. So, and we have a slight difference in diameter between the threaded holes and the dowel pins. Okay, so we're going to go with 2 routines. One spot facing the threaded holes, and then the other one's going to spot these dowel pin holes, and they're going to spot face the bolt clearance holes because they're not going to go to full depth. Okay, so let's so we'll just have those the same depth, so it's the same routine. Okay, so our major diameter of our countersink here is 150 thousandths. Okay, so we're going to go to CAM. Okay, so when we make these operations ahead of time, in order to select and move back and forth between them, we need to right click on the job we want to work on. And you're going to select Make Default Folder. And so that ends up showing up in bold compared to the others. So now every operation you create, under the operation you just selected. Okay, again, we're going to do drilling. We're going to go to drilling. We're going to grab our drill tool. We're going to go to our library. We're going to select our spot drill. And we're going to slow the RPM down to 2000 RPM because we're cutting steel, not aluminum or brass. And we're going to go to geometry and we're going to select the first hole. We're going to do the 632 threaded holes first. Select the chamfer itself. That way it registers that as the top of the hole for our next settings. And then we're going to use a neat selection. If we want to do a whole bunch of the same diameters, we can just pick this box and it'll automatically select all the holes that are modeled of that same size. Okay, and so we're machining 4 holes, and we're going to go to our depths. Okay, so our retract height is going to, our clearance height is going to be based off the retract. That's fine. Our retract height is going to be based off the stock top, which is fine because it's pretty much the same as the model. It's synonymous. Our feed height is also going to be calculated from the top of the part. And our starting point is going to be the top of the hole. And instead of selecting bottom of hole, because we're not sure what depth that really is, it looks like it's a little too deep, we're going to plug in a number. So the diameter of this I measured at 150 thousandths, and we're going to go half of that. So we're going to go negative 0.15 divided by 2, which should give us the proper depth. But we want this to be from hole top. Okay, so we're going to go from the hole top, and we're going to go negative 75 thousandths, which should give us a resultant of a chamfer of 150 thousandths in diameter. You're going half the diameter in depth. Okay, but make sure you have this from hole top selected. We're going to go to the next step. It's just going to do a drilling ramp out. It's steel. It's we're just doing a spot face, so we're going to want to do that. All right, and our feeds and speeds are probably too high as well. We don't want to go 40 inches a minute, so we're going to go down to a cutting feed rate of, let's do 10 inches a minute, and we'll just set all these to 10. We don't really have a ramp. I guess we technically have a feed rate, but let's set them all at 10 inches a minute. Okay, let's hit accept. Here we go. We've got our first 4 spot faces. All right, now we're going to duplicate that so that we can keep the same settings we had. So let's go duplicate. Okay, and then we're going to go to edit. So we should have our feeds and speed set because we did that. We're going to go to geometry, and we're going to deselect the one face. we're going to select the face of one of the 1/8 inch chamfers, and then we'll select the cone of the countersink, and we're going to select all same diameters, which on the first one, and then we'll select the second face and select all the diameters that are that size. So we've now selected all of the holes except for the threaded ones. Okay. Now we're going to go to the next tab on the command, and we're going to leave all this the same except for we're going to change this last parameter. The diameter of this chamfer was 170,000, so negative 1.17 divided by 2 will give us our new depth. So we're going to just go about a little bit deeper. Done our spot face on all the holes.